Hello, hello. Yes, we welcome you back to PSSB. Today we are looking at this question. It comes from Electrostatics. Okay, let us analyze it and we see. It says two identical spheres, X and Y, each of mass 150 grams, are suspended at the same point by an inelastic insulating string. Each sphere carries a charge of 300 nanocoulomb, and the sphere comes to rest in the same position shown below. So question point 8.1 says, give the reason why the angle between each sphere and the vertical is the same. This is the vertical, and these are the spheres. They happen to form the same angle, 25 degrees to the vertical. Why the same angle? Okay, the answer lies in the mass. Both spheres have the same mass, and also the charge. Both spheres have the same charge, and that's the answer. So let's put it down. So that is that. Now we go to the next question. Okay. The question reads, it says, draw free body diagram showing all forces acting on X. Okay. How do we go about this? This is what we know. If this is our X, we know there is a string attached to it in that direction, and that one brings in tension. X has weight, so there's a gravitational force acting on it along this direction, and it is being repelled by an electrostatic force Fe. So what we have here actually is the free body diagram showing all forces which are acting on X. Then we go to the next question. Then comes this question. It says, calculate the magnitude of tension in the string. Okay, how do we approach this question? Okay, the best approach is to use the free body diagram. Okay, let's look at how it is. So this is our free body diagram. And what else can we get from this free body diagram? We know this angle. It is 25 degrees. And if you we have that plane, then this angle is also 25 degrees. Why? They are alternate. So that one gives us an avenue to use components. So if this is our T is acting at an angle, so it has two components. There's a component here, and there's a component along this plane. Okay, you have to know that the component next to the angle is a cos. So what we have here is going to be T cos theta. What we have here is going to be T sine theta. Now, when you have the components, now this force has lost meaning. So we can redraw this one again. And when you draw, what do you have? you have this component, which is t sine theta. You have this component, which is fg. You have this component, which is fe. And you have this component, which is t cos theta. Now we have two equations. Remember that sphere X is in equilibrium, actually static equilibrium, it's not moving. And what do we say about equilibrium? The sum of forces in one direction are equal to sum of forces in opposite direction. So you have two equations already. What is it? T cos theta is equal to Fg. And another one is Fe is equal to T sine theta. And from here, you make a choice of which one is most appropriate. Let us look at here. When you look at this one, well, there's a problem. What's the problem? We don't know the distance between the two spheres to come up with this force, electrostatic force Fe. So that's a dead end. This side requires us to know mass, and mass was given. So this one has a green light. What are we going to say? We are going to say T cos theta is equal to mg. Okay? And T cos theta is known, cos 25 degrees is equal to m. We said m is 150 grams. If you convert it to kilograms, what are you going to get? 0.15 kilograms. You divide by 1,000. Okay, times what? Times g, which is 9.8. So we'll get our t as 0.15 times 9.8 divided by cos 25 degrees. What you get there will be the tension. Let's find it out. So after substitution and rearrangement, we get that one as our tension, 1.62 newtons. Okay, then we go to the next question. Yeah, then comes the next question. It says, calculate the distance between x and y. Okay, how do you go about that one? We have to remember that we ended up with this, and we said that this one is Fg. Okay. Yeah, this one happens to be T sine theta. This one happens to be electrostatic force, and this one happens to be T cos theta for x. So remember, we also have T. So after getting our T, what are we going to do? So armed with our T, this is what we are going to do. Remember, they want distance between x and y, so we are tempted to use that plane. Remember, it's equilibrium. What does it mean? It means that the electrostatic force Fe is equal to T sine theta. What is Fe? Fe is K Q1 Q2 over R squared, which is equal to T sine theta. Okay, what is K? It's 9 times 10 power 9. And what is the charge? The charge is 300 times 10 power minus 9. Okay, and we are looking for the distance between them. But we have to know that this one is equal to T, which is 1.62 times sine 25 degrees. Okay, when you look at this equation, we are finding R as the only unknown. So let's go for it and rearrange to find out R. So after rearrangement, this is what we get. So what do we do? Now we find the square root of both sides, and we are going to end up with our R. Let us do that. So after rearrangement and the computation, this is what we get. We get our R as 0.0344 meters. Okay. With that, we are going to cut this video here. We appreciate your time. Don't hesitate to click the like button. And it is PSSB, Physical Sciences Silver Bullet. See you then. Bye-bye.